Hello, Soham. Let's wait for 2 more minutes. Okay, let's start. Am I audible properly, Soham?
Yes.
Okay. So in the last class, we were doing questions on domain and range. Okay. Try this question. We have to find the range here, and they have given us the domain.
So, is it
Yes, Soham. Hello.
so is it
Your voice is breaking. Is that what you are saying? This is the answer. Okay. Okay, so we just substitute the domain here to find the range of the function. So range of the function is 2 to the power 1 upon x value goes from 0 to 1 minus 1. So this becomes 2 to the power 1 upon. Now we have to solve this interval minus 1. So 0 minus 1 is minus 1 and 1 minus 1 is 0. So the power of 2 is 1 upon, and the denominator values moves from minus 1 to 0. Now this is the very important part. So see, you are on the left side of 0, right? From minus 1 to 0 means we are on the left side of 0. We are moving here. So when you are very near to the 0, so there will be a very small negative value here. So 1 upon very small negative value. 1 upon very small negative value. Okay, so that goes to minus infinity. And 1 upon minus 1 will be minus 1 only. Right? So the range will become 2 to the power minus infinity to 2 to the power minus 1. Now 2 to the power minus infinity is 0. 2 to the power minus infinity means 1 upon 2 to the power infinity. So that is almost 0. And 2 to the power minus 1 is 1 upon 2. So the range of the function comes from 0 to 1 upon 2. Okay. So this is the important part. Whenever the interval in the denominator is from minus 1 to some positive values, or 0 is appearing basically in the interval. So you have to take care of that 0 thing. Yes, any doubt in this? Okay, try this. Last minute. Okay, so so your voice is not clear, so you can use the chat also to answer it, or if you want to ask the question, you can use the chat. We have to find the range. Okay. Okay, so see, if you even find the domain of this thing, so the domain is the easy part. All real values except 7, right? But even if you know the domain, you cannot put each and every real number and then find the value of y, right? So what is the basic idea for finding the value of y in this kind of situation? So now see, when y is represented in terms of x, so x will act as a domain for the y, right? Now if I find x in terms of y, so how do we find x in terms of y? Let's cross multiply. So x y minus 2, so x comes out to be 7y plus 3 upon y minus 2. Now this is the function in y. Okay, both are same basically, but now you have find out the x in terms of y. So now if someone asks what is the domain of this function, so you will say, sir, domain of this is all real values except 2, right? So when you find the domain here, so what is actually you are finding? You are finding the possible values of y, and possible values of y in actual represents the range of this function. Okay, so for linear upon linear, this works when the function is linear upon linear. Okay, if there is a quadratic in the numerator or denominator, then you cannot find y x easily in terms of y. Yes, any doubt here in this? So this is the range of the function. Now for this particular type, linear upon linear, when your function is, that is ax plus b, and let's say cx plus d, so the range of the function will be all real values minus coefficient of x in the numerator divided by coefficient of x in the denominator. Okay, so this is what you can see here. all real values except coefficient of x in the numerator divided by coefficient of x in the denominator. Okay. And why is this thing only? Why we are doing this thing? So you can see, if I substitute y equals to a upon c, like here a upon c is 2 upon 1. So you can see if I substitute y equals to 2. So this is 2x plus 3 upon x minus 7. So when you cross multiply, it becomes 2x minus 14 equals to 2x plus 3. 2x will cancel out from both the sides. So you cannot take the value here which makes the coefficient of x in the denominator and coefficient of x in the numerator equal, because they will always cancel out then. So how you will find then x? Okay, so that's why we are removing this value. Yes, any doubt here in this part? So this you need to remember to save the time in the exam for this particular type. Try this. You have to find the range. Okay, we are doing the range questions. Last minute. Okay, so for finding the range of y, we have to use the range of cos x. So range of cos x is minus 1 to 1. So denominator part will become 1 minus. When 2 will multiply inside the interval, it becomes minus 2 to 2. So 1 minus of minus 2 will become 3, and 1 minus 2 will become minus 1. So from minus 1 to 3, 0 will be there in the interval, right? That is the point where this becomes not defined when cos x is half. So you have to break the interval at 0, then you can find the range easily, because 0 cannot be part of the interval in the denominator. Now solving the first part, 3 upon minus 1 to 0. So 3 upon some negative quantity which is very small to the 0 is minus infinity, and 3 upon minus 1 will be, and since this has close bracket, so you will use close bracket here. Now for 3 upon 0 to 3, so now this time you are on the right side of 0, so there will be a small positive quantity. So 3 upon very small positive quantity means infinity, and 3 upon 3 will be 1. So for final range, take the union of these two sides. Yes, any doubt here in this?
No, sir.
Okay. Amitesh, any doubts?
No, sir.
Okay, try this. We have to find the range. Last minute. Okay, so we have two options to solve this. This is the quadratic, right? So first, basic method. You can make it a perfect square. So if I take minus common, this becomes x square minus 2x and plus 3 is this. So x square minus 2x plus 1 and minus 1. So this will become your perfect square. So this becomes minus of x minus 1 whole square plus 1 plus 3. So 4 minus x minus 1 whole square. Now any whole square, this is basically the, when you take any value of x, it becomes perfect square. So it is a positive quantity, or when x is equal to 1, it becomes 0. So the perfect square will always belongs from 0 to infinity. Any perfect square of a number will always belongs from 0 to infinity. So this will also follow the same trend. So 4 minus 0, 4, 4 minus infinity minus infinity. So this will be the range of this quadratic. Yes, any doubt here in this? See, range questions, domain has some specific points that whatever is inside the root must be positive, whatever in the denominator should not be 0. So domain has some monotonous pattern, but in the range you have a lot of variety as per the type of the function. Method 2. So if I'm talking about the general quadratic, if a is positive, so what is the shape of the quadratic if a is positive? Upward parabola or downward parabola?
Sir,
Sir,
upward.
Upward parabola. So when a is positive, and similarly when a is negative, so the vertex of this is called the vertex, the lowest point of this u shape, or here it is the highest point of this mountain shape. So the vertex has coordinates x comma y. So x is minus b upon 2a and y is minus d upon 4a. And here also the coordinates are same. Only difference is at upward facing the coordinates will represent the minimum point. In downward facing the coordinates will represent the maximum point. So the y coordinate is this. This is the maximum value. So you can see when you go in the upward direction, so this is the minimum value and you are going towards the plus infinity. This is, let's say this is your coordinate axis. So from minimum point you are going towards the positive infinity. So for this case, range is minus d upon 4a to infinity if your leading coefficient is positive. And for the second case, range is minus infinity to minus d upon 4. D is your, as usual, discriminant of the quadratic, because here if I draw the coordinate axis like this, so from this highest point you are going towards the negative infinity. So you can use this also in case of quadratic. Yes, any doubts in this? Have you studied this thing in the ninth batch? You studied quadratic chapter in the ninth.
Yes.
Okay, so you can use this also. Okay. Try this. You have studied permutation and combination also, right?
Yes, sir.
Okay, so try this. You have to find the domain and range both of this new function hx, which is formed by multiplying the two functions fx and gx. last minute. Okay, so our hx is x plus 1 c 2x minus 8 into 2x minus 8, right? So whatever is the values you can take from x here, whatever is the value you can take of x here, you have to take the common values of both the ones. Okay, so see, this looks like that you can simplify this, you can open this and simplify this. We will check that method also, but go by the basic first. So when we write NCR, so what is the nature of N, R? What is the relation between N and R? N is a positive quantity, basically a natural number. So N belongs to natural number. R belongs to whole number because R can be 0 also. And N must be greater than equal to R. These are the three conditions on NCR. So if we follow these three conditions for the first one, so x plus 1 will be greater than 0, x greater than minus 1. Second condition, 2x minus 8, that is r will be greater than equal to 0. It means x will be greater than equals to 4. Third condition, x plus 1 will be greater than equals to 2x minus 8. So 9 and this. So x is greater than minus 1, x is greater than equal to 4. So if we take this situation, this will already be covered. So the common part of these two is this one only. So x is greater than 4 and x is less than 9. So here we got from the first part x belongs to 4 to 9, right? And x is basically a natural number. Second part, 2x minus 8 is positive now. So it means x is greater than 4. X plus 1 is greater than equal to 0. So x is greater than equal to minus 1. 2x minus 8 is greater than equals to x plus 1. So here x is greater than equal to 9. So here we have 3 greater than inequalities. So which one you should pick, which will satisfy all the values? Yes, Soham, Amitesh. If we have to take the common part of these three solutions, so what is
So x is greater than equal to 9.
yes, x is greater than equal to 9. So now common part of these two, this ends at 9, this starts at 9. So common part of first and second is x equal to 9, right? Now if x is equals to 9, so domain is x equal to 9. So just substitute here. So 9 plus 1, 10, and 9 to the 18 minus 8, 10. So 10 c 10 is 1. This also becomes 10, this becomes 10. So range of the function is 1 and this is our domain. Right, now if we solve by simplification approach, let's see what happens. So x plus 1 x plus 1 factorial, 2x minus 8 factorial, and difference of this, it means minus x plus 9 here, 2x minus 8 factorial, x plus 1 factorial, and minus x plus 9. This cancels, we have left with only 1 upon minus x plus 9 factorial whole square. So whatever is written in the factorial must be greater than equal to 0. So it means your x is less than equals to 9. Now as per this situation, then x can be 8 also, 6 also, 7 also, right? So from here, after simplification, you are not getting the proper value. Why? Because we have directly cancelled out this thing. From here also you have to check. Now see, suppose it as per this I can take x equals to 3. So x equal to 3 will satisfy this, but will it satisfy this factorial? 3 2 is 6 minus 8 minus 2 factorial. So you have cancelled minus 2 factorial with minus 2 factorial, but minus 2 factorial is not valid. Okay, so whenever there is a question of domain and range, instead of simplifying the things, go with the original function and apply the concepts in the original function. Okay. Yes, any doubt in this till now, domain and range of the function? Okay. Next is, there are some very important functions which will be frequently used in the question, so we must have the complete idea about that function, that how that particular function works. So first function is your polynomial function. So this you have studied from the 8th 9th class. So the polynomial function is of this form: an x to the power n, an minus 1 x to the power n minus 1, and like this. Okay, your cubic function, your quadratic, your 4-degree function. So they are all polynomial, but the condition is the power of the variable must be a whole number. First thing. Second thing, this is the polynomial of degree n, right? Because the highest power of x is n, so it is a n degree polynomial. If it is a n degree polynomial, then its coefficient should not be 0, otherwise it becomes n minus 1 degree polynomial, right? So if we are saying this is a n degree polynomial, so an should not be 0, right? And a0, a1, an all are real numbers. Now domain of this polynomial, domain of what do you think, what should be the domain of this? Is there any mathematical hurdle here?
No, sir.
So domain of the polynomial is R, right? Now if I ask, see, this is very fundamental thing. Let's say my fx is x cube upon x. Is this a polynomial or not?
Sir, no. Oh, sir, it is. Sir, it is.
It is. Okay. Soham, did you get the question?
Yes, sir.
Yes. So what's your answer? Amitesh said it is a polynomial. What about you?
So it's not a polynomial.
And why?
So because domain of this function is not R.
Yes. See, you are, if you are simplifying this and you write like this, so fx equal to x square looks a polynomial, okay, because power is a whole number. But if you look for the domain of this, in original function you cannot put x equal to 0, right? It is not valid for x equal to 0. So domain of the function is all real except 0. But in the original polynomial function, domain must be all real values. So this is not a polynomial function. Okay. But you can see in the NCRT or in some books they have this question and they said this is a polynomial because that time you haven't studied the domain thing. Okay, so for the, like, the basic thing, they simplify this, or they will give you that x is not equal to 0, then you can say, sir, we can cancel it. But if x is not equal to 0, then how the domain will become all real? Okay, so when we study properly the polynomial, this is not a polynomial. Okay, now these are very important points. Range of odd degree polynomial is R. So you can see, if you have a polynomial, okay, I'm taking just example, let's say x to the power 5 plus 4x cube minus 2x square plus, this is my sum, odd degree polynomial, right? So now see, you can put all the values of x in the polynomial. It means when you draw the graph from minus infinity to plus infinity, you are putting each value of x on the number line, so you will get a respective each value of y in the in the y axis, that the function will not be broken at some point like this, then function start with this, so there is no function in between. It's not like the situation. So for each value of x in the real number, you will get some value of y, so there won't be any break in the function, right? So now if I check for infinity, if I substitute infinity, so the highest power will go towards infinity. X to the power 5 is the biggest one among all these, right? So f infinity means the value of the function is going towards infinity. If I substitute minus infinity, so minus infinity to the power odd will give you minus infinity. So you are covering all the values of y from minus infinity to plus infinity, right? So this must be the kind of graph we will get. So x is from minus infinity to plus infinity, and y is infinity here, minus infinity here. So when x is plus infinity, y is also plus infinity, so you are somewhere here towards infinity. When x is minus infinity, y is also minus infinity, so you will somewhere here. So your graph can have any shape like this, can go anyway, but it is going from minus infinity to plus infinity, so it is covering whole values on the y-axis. So the range of odd degree polynomial is always all real numbers. Without thinking of anything, range of odd degree polynomial is all real numbers. Yes, any doubt here in this part? Okay. Range of even degree polynomial is never R, or you can say that range of even degree polynomial is always a proper subset of all real numbers. So why is it so? And also see, here everything depends upon the coefficient of the odd power. If I take suppose minus 2 here, so when you substitute infinity, this will go towards minus infinity, right? So your graph will be from like this. Okay, so it's not like whenever infinity is put, you will always get plus infinity. Everything depends upon the coefficient of the highest power. Now if let's say fx is, here I am taking minus 2x to the power 4 plus x cube minus 7x square plus 1, right? So when I substitute infinity, what do you think, where this value will go towards?
towards negative infinity.
It will go towards minus infinity because see x to the power 4 is largest among all these, na? So infinity to the power 4 will be the largest among all these. So no matter what kind of values this will give, this is the highest value. So and it has a negative sign, so it will go towards minus infinity. Same way, if I substitute minus infinity, what do you think where it should go? When you substitute minus infinity in this, the value of the function will go towards which infinity, plus or minus?
Minus infinity.
It will again go towards minus infinity because when you substitute x equal to some negative quantity because of even power, it again become positive. So it is going towards minus infinity. Now okay. So when x is infinity, y is minus infinity. Here. And when x is minus infinity, y is again minus infinity. Okay. So there won't be any function which will go towards the plus infinity and then again comes towards the minus infinity. So when you have to join these 2 points, and you can also see domain is R, so you will get all the real values here. So if the function is going like this, okay, any function is going like, at some point here the function have to turn to come at this point. So if the function is turning back from some point, so the values after this is not covering in the range. Okay, so for even ones, the range will never be the complete R. It is always a subset of R. This is subset of. Okay, so just by looking at the even degree polynomial, you can say that yeah, it will depends what will be the range. Okay, it can be from minus 2 to minus infinity, it can be from minus 6 to plus infinity like in the quadratic. Okay, that depends upon the type of the function they will give, but the range will never be complete R, that is for sure. Okay, so they will ask sometimes this kind of questions in the theoretical ones. Fx equal to 0 is a polynomial, but its degree is not defined, right? So why its degree is not defined? This is part of your even NCRT also. Yes, Soham, Amitesh.
Yes.
Yes,
So like it can be expressed in the form 0 into x to the power n, where n can be any uh,
yes, very good. So
integer.
we can write 0 into x to the power 2. Someone can say, sir, I want to write x to the power 7. So both the polynomial represents the same polynomial, but you are not able to judge the power of x, that which power should be taken. So in maths, whenever you are not able to take the unique value, okay, so that thing won't be defined. So degree is not defined. Now this is the important part. The GE will definitely ask question on this thing. Okay, that's why I have highlighted this. So if you see, if you have any polynomial function, okay, same polynomial function of any degree, which is satisfying this kind of situation. Now this is basically known as functional equation. Okay, this we will see at the last of the chapter, but for the basic idea, we call this situation as a functional equation. So why functional equation? You can see this is a function in x, this is a function in 1 upon x, same function in x, function in 1 upon x. So there is no free x and y here. Okay, so this is known as functional equation. Now this equation is valid for all x belongs to R. Okay, and R, see here you are now taking 1 upon x also. Okay, so you can take 1 upon x only when x is not equal to 0. Okay, so this is the domain of this functional equation. Okay, where fx is a polynomial function. So what kind of polynomial function will satisfy this equation? So there are two types of polynomial function, 1 plus x to the power n and 1 minus x to the power n. These two polynomial functions will satisfy this, and n is a whole number. Okay, so you can verify this also. Our functional equation is fx into f of 1 upon x equals to sum of these two. So if I am saying this is my polynomial in x which will satisfy this equation, and n is a whole number. So let's say n is 1. So my function will become 1 plus x. Now if I change x with 1 upon x, so the function will change to 1 plus 1 upon x, that is x plus 1 upon x. So if I take the product of these two as per the LHS side, so my LHS will be x plus 1 whole square upon x. The RHS side, 1 plus x plus x plus 1 upon x. So if I take x plus 1 common from the numerator, it becomes 1 plus 1 upon x. When you take the LCM, same thing. Okay, so this is very famous functional equation, and they just give you that there is some function fx which satisfies this equation, and they will ask you to find something like f of 2 you can find. So basically we have to figure out which function is satisfying the given condition. They will give you one more condition. Okay, yes, any doubt here in this thing or any of the parts in the note?
No, sir.
Okay, so let's see the question on this. Just read this question, then we will do it together. So now my choice is either fx is 1 plus x to the power n or fx is 1 minus x to the power n, but it cannot be both at the same time. So they have given one condition that f of 5 is 126. So if I substitute 5 here, it becomes 1 plus 5 to the power n. So f of 5 is 126, 1 plus 5 to the power n. So n comes out to be 3, and n is a whole number, so we are getting everything in place here. Now let's check here. F of 5 is so 5 to the power n is minus 125. Now when the base is positive, no matter what you choose as a power, it will never give you a negative result. So not possible. So in this case it is not possible, but in some other cases this will be your function. So you have to check both. Okay, but generally if you are checking one and it got rejected due to not getting the proper value of n, you can directly take the second one as your answer. Okay, it's not like you have to check both at always at. Okay, so now this is my function. So what is my f of 3? So n you already got, n is 3 by solving this. So the function is 1 plus x cube. So we want to find f of 3. Okay. So this is the very basic question on this functional equation thing. Yes, any doubt in this? How to judge which one is correct? They will always give you one of the values of the function. Otherwise it becomes impossible to judge. Okay. Okay, let's do this one more question together. The next question you will try. Now this is not related to your functional equation because this is not following that functional rule. This is based on your general polynomial function. So now let's see, your general polynomial function is an x to the power n minus 1 x to the power n minus 1 till a naught, or let's write one term a1 x plus a naught. Now if I want to create these two polynomial functions, so in first function x must be replaced with x square, so change x with x square, so this becomes x to the power 2n, this becomes x to the power 2n minus 2. This is my first function. Second one is p of x minus 1, so I have to change x with x minus 1, so an x minus 1 to the power n plus an minus 1 x minus 1 to the power n minus 1, a1 into x minus 1 plus a naught, right? But this function is multiplying with x square also, so let's multiply this with x square. So this becomes an into x square x minus 1 to the power n, an minus 1 into x square this is my function. So see, if these two are equal, right, so whatever is the degree of the function on the left side, same degree should be followed by the function on the right side. Only then it will be equal, right? So what is the degree of this function?
2n.
2n. So degree on LHS is 2n. What is the degree on RHS?
N plus 2.
N plus 2. If you open this thing with the binomial, so highest power of x you will get is n, and when multiply with 2, so it become n plus 2, and rest of the terms will have lesser degree than this. So degree on RHS is n plus 2. So these two degrees must be same. So n comes out to be 2. It means whatever polynomial you have assumed is a quadratic polynomial. So our px is ax square plus bx plus c, a not equal to 0. Now what they have asked, and find px. So we have to find abc also. So how do we find abc? So we abc are three variables, so we need three equations to find three variables. Now this one, p of x square equals to x square into x minus 1 plus 3. First part, if I am substituting x equal to 0 in the given equation, it becomes p of 0 equal to 3. Second part, if I am substituting x equal to 1, so it becomes p of 1 equals to p of 0 plus 3, that becomes p of 6. Third, when x is 2, so it becomes p of 4, right, equals to 16 p of 1 plus 3. Now p of 1 is 6, right? Sorry, this becomes 4. So 6, p of 1 is 6, so 24 plus 3, 27. So we got three values of the polynomial function at 3x. So now using first one, p of 0 is 3, so when you substitute x equal to 0, c comes out to be 3. Next, p of 1 is 6, When you substitute x equal to 1 in the polynomial equation, c is 3, so a plus b comes out to be 3. P of 2 is 27. So when you substitute 2, 4a plus 2b plus c is your 3, so it becomes 24. So it will be common, 2a plus b equals to 12. So if I subtract these two, so sixth minus fifth equation, so b got eliminated, a comes out to be 9. Right? So a is 9, so b will be minus 6. So polynomial will be 9a square minus 6b plus 3. We will take 3 common, so 3a square minus 2b plus 1. Just check any calculation mistake we did. P of 0 will be 3, so c will be 3. X equals to 1. 6, x equals to 2. So x square will be 4. P of 1 is 6, 27. Equals to 2. P of 1 is 6. A plus b is 3. P of 2 is 27. So 4a plus 2b plus c, right? C is 3, 24. Taking 2 common, so 2a plus b, 12. 12 minus 3, 9. And b will be minus 6. So yeah, this will be the correct one then. Yes. Any doubt here in this? Okay. So next question is on you. Try this.
Sir, is it minus x plus 1?
Uh, it is also a quadratic. You can also check if your function comes out to be minus x plus 1. So is it satisfying this functional equation? So p of x plus 1 will be, so that becomes minus x. So when you subtract these two,
No, sir, no mistake.
okay, last 1 minute. Okay, so let's find the degree on the LHS first. So px an x to the power n a1 x plus a naught and p of x plus 1. So an x plus 1 to the power n an minus 1 x to the power n minus 1 x plus 1 to the power n minus 1. So when we subtract these two, okay, so when you take an common from the first term, x to the power n minus x plus 1 to the power n plus an minus 1 x to the power n minus 1 minus x plus 1 to the power n minus 1, and like this a1 x minus x plus 1. Now from the first term you will get the degree of the this polynomial. So you can see x to the power n and you will get x to the power n from here. So x to the power n will cancel out. So from this part what is left is x to the power n minus 1, right? Here x to the power n minus 1 will cancel out, but this x to the power n minus 1 will remain. So degree on the LHS. Yes, anyone have doubt in this, figuring out what is the degree of your LHS part? How it is x to the power n minus 1?
No, sir.
Okay, so degree of LHS is n minus 1, and degree of RHS is 1, so they must be equal. So your polynomial will be then quadratic polynomial. Now what they have given is p of 0 is 1. So p of 0 is c. So c will be 1. Now they have given this functional equation px minus p of x plus 1 equals to 2x plus 1. So when I substitute x equal to 0, so p of 0 minus p of 1 equals to 1. P of 0 they have already given us 1. So P of 1 is 0. So P of 1 is 0 means P of 1 is a plus b plus c equal to 0. C is your 1, so a plus b plus 1. Okay. In the same way, when I substitute x equal to 1, my functional equation will become p1 minus p2 equals to 3. So p1 is 0, so p2 comes out to be minus 3. So p2 means 4a plus 2b plus c. C is 1. So 2a plus b is minus 2. So when you subtract the equations, a comes out to be 1, and if a is 1, then b will be minus 2. So x square minus 2x, and c is our 1. Yes, any doubts in this, anyone? Okay. Now rational function. So rational function is very much similar to your rational number. So definition of rational number is any number which can be represented in the form of p upon q, where p and q are integers and q is not equal to 0. Okay. So same, a rational function is a function of the form px upon qx. Now p and q are the polynomial functions. Okay, they are not the numbers anymore. And same thing, whatever is your denominator is not equals to 0. So q of x is not equals to 0. Okay. So domain of the rational function, all real values minus those values of x at which q of x is 0. Okay. Basic definition of rational function. Identity function. So identity rule or identity element you must have heard somewhere. Does anyone remember? Multiplicative identity.
Yes, sir.
Okay, so identity means if you are doing some operation on anyone, but its identity won't change, it will remain the same. So that is basically the meaning of identity in the mathematics. So identity function means that if there is a function from set A to set B, okay, now whatever input you are giving, if you are giving 2 as an input, so you are getting 2 as output. If you are giving minus 5 as an input, so you are getting minus 5 as a, so whatever is your input, same is your output. This is basically y equal to x function. So whatever value of x you will put, you will get the same value for the y. Okay. So this is called the identity of A. Now, because why we are saying identity in set A? Because A set is representing the domain. So whatever is your input comes from the domain, same you will get as a output. So whatever is your input set is your identity in that set. Okay. This is very important when we study the inverse thing, na? And so this will be very helpful. Okay, so you should have clear meaning of identity. It is the simple one. Whatever you give, same you will get. That's it. Constant function. Okay, so as the name suggests, the function is not changing. So when the function will change, when you put different values of x, you will get different values of y. But if on putting different values of x you are getting the same value of y, so that kind of function is constant function. So this function, for example, this is a function. No matter what you put x here, you will always get 2 by 3. So a function from a to b is said to be constant function if every element of a has the same image in b. So this is set A, this is set B. If every element, whatever you are putting, here you have multiple possibility. So if every element is connected to the same element, so it means your output is only this element. So no matter what you are putting from here, you always get the same output. So that is the constant function. So it is represented like this. For all x belongs to the domain set A, and the output k belongs to the codomain set. So domain is all real numbers for this kind of function, and range is this particular number, no matter what you choose. Exponential function, this is kind of important. Okay, so function fx in the form of a to the power x, which can also be represented like this, e to the power x ln a. So when you shift that x in the power, right? So since this base and log base is same, so this becomes a to the power x as an answer. So same representation. Okay, same function with different representation. Now what is the condition on the exponential function? First thing, the base must be always positive. Base is not equal to 1. Why we are not taking equal to 1? Because in function what we want is variety, that if you are changing the input, you must get the different outputs, right? So if the base become 1, so if you change x, you always get a 1, so it becomes boring. So that's why we avoid a as a 1. And the range thing, the domain thing. Now the power is, can be any real number. It won't affect the mathematical conditions anyway. So domain is all real number, is called an exponential function. Domain is R, and range is all positive numbers, because if you have, suppose, let's say fx is 3 to the power x, right? So this will always give you a positive number. This thing will never become 0, no matter what you take x as a, even if you take the minus infinity, so it will be very near to the 0 but not exact 0, right? So the range is r plus. Now coming to the graph of the exponential function. So there are two graphs, okay, depending upon the nature of the base. Okay, so we have two cases. When the base is greater than 1 and when the base is between 0 and 1. So now you can take the example. See, whenever you want to draw the graph, now take some basic example like this 3 to the power x. Now the base is greater than 1, right? Now what do you think if I substitute x, okay, minus infinity? Here minus infinity to. So if I substitute x equal to minus infinity, what will be the value of 3 to the power minus infinity? Yes, we have seen this in one of the examples. Huh?
So 0.
It's almost 0, right? So when x is minus infinity, y will be 0. So it won't touch the x-axis, but it will be very near to the x-axis, right? Now what happens if you start increasing the value of x? The overall value will increase or decrease? Just the basic example, 3 to the power 4, 3 to the power 7. So if you are increasing the x, what is the nature of the value of y? Right? If we go from minus infinity to plus infinity, so we are increasing the value of x, right? So you can take the basic example. If 3 to the power, let's say 2, so 3 to the power 2 is 9. If we take 3 to the power 5, so 3 to the power 5 is 243. So when you increase the value of x, if you are increasing the power, so the value of overall function will increase. So the graph of the function will be like this. Okay. So if even you take 10 to the power x, so the graph will be, the shape of the graph will be this. The function, the 10 to the power x might have some different kind of values from this point, like the function will go here very near to the infinity and then they go like this, but this point is same for every a to the power x, because when x is 0, this is 1, so this point is 0 comma 1. Okay. Now try for this when the base is between 0 and 1. Try to draw the graph for this and let me know. You can share your answer in the WhatsApp group where we send the reminders generally. Okay, because in chat, I guess you.
No, sir, so only admins can message them.
Sorry.
So we can't message, sir, the admins can message them.
Oh, you can't message in the group.
Yes, sir, we can't message.
Okay, okay. Okay, I will draw it, then you can confirm whether you got the same graph or not. Now, so if the base is less than 1, so we have the function of this type. Let's take an example. Fx is 1 upon 7 to the power x, right? So when the power is minus infinity, so 1 upon 7 to the power minus infinity will give you, what will be the value when x is minus infinity? 1 upon 7 to the power minus infinity is 1 upon 7 to the power minus infinity, which is basically 7 to the power plus infinity. When x is minus infinity, y is plus infinity. So now when you start increasing the value of x, the denominator value is increasing, so the overall value of the function is decreasing. So the graph will be like this. So when x approaches to positive infinity, the value of the function will become very small. Okay, so the point is still 0 comma 1, because when x is 0, y is 1 here, but the graph will be like this. Yes, does anyone get this same graph? Soham, Amitesh.
Yes, sir.
Okay, Amitesh,
Yes.
any doubts?
No, sir.
Okay, so this is the graph of exponential functions. Now logarithmic function. So you have already seen the log x or base a, right? So whatever is inside the log must be positive number. So x must be positive. So domain is r plus, and whatever is the base must be positive and not equal to 1. And range of the logarithmic function is all real values. Okay. So now just observe the one thing. In exponential function, the domain is r. In logarithmic function, the range is r. In logarithmic function, domain is r plus. In exponential functions, the range is r plus. So in logarithmic and exponential function, domain and range interchange their roles. So whenever domain and range interchange their roles, we call such functions as inverse functions. So exponential function and logarithmic function are inverse of each other. An inverse function we will study again in detail in the last of the chapter. It is second last topic, I guess. But for a moment I am explaining this thing, that they are known as inverse to each other because their domain and range has interchanged their roles. I have studied the definition of the inverse of a relation, that if you are going from this to this, and if you start going from this to this, so now this becomes your domain, this becomes your range, but initially this is your domain, this is your range. So it is satisfying the definition of inverse. They are inverse of each other. Okay, now coming to the graphical part. So here also the graph will depend upon the nature of the base. So first case, when your base is greater than 1. Second case, when your base is between 0 and 1. Now this function y equal to log x base a can be written as x equals to a to the power y. Okay. So now if your base is greater than 1, now see, x and y interchange their role. So now you have to go in the direction of y to find the values of x basically, right? So if you are at minus infinity and base is greater than 1, so let's say x is 3 to the power y. So when is y is minus infinity? So your y is minus infinity here. So what is the value of x? 3 to the power minus infinity, x will be 0. So you are very near to the y axis. Now if you start increasing the value of y, the value of x start increasing. So you start from here, very near to the y-axis. When you start the value of increasing the value of y, the value of x is increasing. So this will be the graph of the logarithmic function. Now this point will become 1 comma 0. In exponential we got 0 comma 1, here you got 1 comma 0. Now this one, here let's say x is 1 upon 5. The same, when y is minus infinity, x will be plus infinity. Y is minus infinity, then x will be plus infinity. So we are here. So when you start increasing the value of y, the value of x will decrease. So the graph of the function will be, you can think like this. When y is plus infinity, so 1 upon 5 to the power infinity means it is very near to the 0. So we start the graph from here. So this point is same again, 1 comma 0. But now the graph is decreasing one. Okay. So this time we have used y infinity and minus infinity. Okay. So whenever you want to draw the graph of any basic log, just take the example. If you are confused in at any point, then you will get through it. Yes, any doubts here in this? Okay. Next is absolute value function, which you have already studied as a modulus. So a function mod of x is called the absolute value function or modulus function. Then how we define the function? So mod x is x, means if you put any positive value inside the mod, let's say 7. So mod of 7 is 7. So whatever is inside the modulus, same is outside. So if x is any positive or 0, then whatever is inside the modulus, same will be outside. But if x is a negative quantity, let's say minus 2, minus 2 becomes plus 2. So how this become plus 2? When you have put one minus from your side, right? Whatever is inside the negative quantity, you have added one minus from your side. So if x is a negative quantity, you have added minus from your side. So it becomes x is less than 0, so it will open with minus sign. So domain is all real number, it is valid, mathematically valid for all real numbers. But range is 0 to infinity, because it will always give you either 0 or positive values as output. Signum function, this must be a new function to you. So see, what is signum function basically is, this is defined as this. If you put positive value in place of x, the signum function will, first here we have the graph of the modulus also. So when x is positive, y is equal to x. So y equal to x, graph is, and when x is negative, so y equal to minus x. So y equal to minus x is, here x is greater than equal to 0. This V-shaped graph is the graph of the modulus. Yes. So in signum function, if I give positive input, the signum will always give you 1. So if I suppose someone says 7.2, so value of signum function is 1. If someone put 11.3, value of function is 1. When you substitute x equal to 0 as the input, signum function will always give you 0. And when you substitute negative input here, minus 8, minus 1.5, minus 0.6, anything negative goes inside the signum function, it will give you minus 1 as the output. Yes, any doubt here in this signum function? This is very simple function. Now this signum function can also be written in different form as mod x upon x when x is not equal to 0, and x is 0 then it is 0. So what we have basically done is we have combined these two branches into this single branch. How? When x is not 0, so it means either x is positive or negative. So x is positive, so mod will open with positive x, so it become x upon x. That is one. When x is negative, mod will open with negative sign, it will become minus 1. So this is one of the important substitution which we need sometimes. Signum of x equal to mod x upon x, x not equal to 0. So x into signum of x is basically mod x. So sometimes we need this mod x in the situation, so we replace x into signum of x with mod x. So find the domain and the range of the following and draw the graph. And before this, we have graph of the signum function. So here x is 0, this side x is positive, this side x is negative. So when x is 0, the signum function will give you 0. When x is positive, signum will always give you 1. So your y is equal to 1. So you will draw a line y equal to 1. When x is a negative quantity, signum will give you negative 1. So you will draw y equal to minus 1. So this is the graph of the signum. This, then 0, and then always 1. At x equal to 0, you have to mention hollow circle that there is no value at x equal to 0 because you have already. Yes, any doubt here in this graph, signum graph? Now signum of x cube minus 1. So we have to find domain, range, and we have to draw the graph also. So domain x belongs to all real numbers because there is no root, there is no denominator, every value of x is defined. Now for the range part, range you just have to check, are you getting positive, negative, 0 values here or not. So if I take x equal to 2, 8 minus 1, 7, positive value, so signum will give you 1 as the output. If I take x equal to 1, so 1 minus 1, 0, so signum will give you 0 as the output also. If I take x equal to minus 3, so minus 27, minus 21, minus 28. So we are getting all kind of values here. So range of the function is minus 1, 0 and 1. And how did we check? We just check whether we are getting all different types of value, positive, negative or 0 or not, for some values of x. Now coming to the graph of the signum function. So see, whenever, this is the basic idea. Whenever you have to draw the graph of signum of fx, fx is any function. So x cube minus 1, you have to first analyze the graph of x cube minus 1. So first thing, x cube minus 1 will have how many roots? If you factorize this a cube minus b cube, a minus b, a square plus b square plus ab. So this has p less than 0, so you won't get any real root, so only real root is x equal to 1, and this is a cubic polynomial, right? So range will also be r. So the graph will be like this. This is the root when x is 1, y is 0. We are drawing y equal to x cube minus 1. And when x is plus infinity, y is also plus infinity. When x is minus infinity, y is also minus infinity. And this will be the graph of y equal to x cube minus 1. Now you just have to figure out when the values of the y is positive, when the value of y is negative, and when the value of y is 0. So when y is 0, y is 0 here. So signum of y will also be 0. Now from this point and above, the graph is positive, right? So y will be, signum of that will be 1. Okay, so from here the signum of will be 1. If you take this value is positive value, so for positive value signum will give you 1. Suppose let's say here it is 1.2, 1.2 cube minus 1, so you will get something value of y, so that is the positive value. So for that positive value signum will always give you 1, right? And the below graph is negative graph. This part is negative, representing negative values of y. So whenever y is negative, signum will give you negative 1. So so if I separate the graph, this is our point 1 comma 0. So here y is 0, it means this is that single point. Now just above this point, just below this point, so this is the graph of signum of x cube minus 1. Yes, any doubts here in this, anyone? How do you draw a graph of signum of any function if they have given inside the signum? Try this. What will be the domain, range and graph of this? what is the domain and range?
Domain R range is +1 -1 0.
Yes. So domain is all real values because sin x is defined everywhere. The range is, since output of sin x is plus minus 0, so range will have plus minus 1 and 0. Now coming to the graph of the signum of sin x. So first let's draw the graph of sin x. This is the graph of sin x. So we have to check when the graph is positive, when the graph is 0. So graph is 0 at these points. So signum will give you 0 value at these points. Now from these 2 points the graph is positive. So signum of this part will give you value 1 and the highest value of sine is also 1. So this is the value of the signum. Same goes for here. So these lines have the graph of the signum. So if you separate out the graph of signum of sin x properly, what we have is 0, 5. So at 0 value is 0. Now between 0 and pi the value is 1. Between pi and 2 pi the value is minus 1. Between minus pi and 0 value is minus 1. Between this so this is the graph, the green part, dotted part, and this one. So you can repeat this graph at other intervals also. Yes, any doubt in this graphical part, anyone? Okay, try for this. Okay, we will discuss this in the next class. And okay, after the last class, I have given some questions in the assignment. So, did you got the assignment questions in the class pro? Soham, Amitesh?
So we're not finished.
Soham, you can message. I guess there is some interference in your speaker. What about you, Amitesh?
Sir, I don't think I received it.
Uh, have you regularly check your class pro account?
Oh, sir, Class Pro. No, I didn't check Class Pro.
Because we can give you assignments through the class pro. Okay, so you have class pro account credentials, right?
Yes, sir.
Okay, so after every class, okay, on the same day or maybe on the next day, I will assign some questions from the module. You have received module, right? So you have to solve those questions from the practice. Okay, so just always check the class pro. Okay, and I have also shared the Google Drive link in the group, and I added that link in the group description also, where you will get your notes, your recording of the class, right? So, an assignment for assignment, just check the class pro. Okay, so today also you can check the class pro. You will get the assignment details, which question numbers I have mentioned from the module, examples, exercise, everything. So just try them, okay, because otherwise this all this learning won't be fruitful until unless we practice the questions. Okay, so that's it for today. Okay, thank you everyone for joining.
Thank you, sir. Bye, sir.
Okay, bye.